Hello! I hope you've had a good night's sleep and can give me your attention. Following from the previous video, introduction from Ed Sexton's book Dawkins and the Selfish Gene, this is a quick and very general summary of the summary Richard Dawkins gives himself in the 1989 edition of The Selfish Gene of the Fundamental Mechanism of Evolution. This summary doesn't contain a discussion of what is a gene actually, in what way this fundamental replicator contributes to selfishness and altruism. These concepts appear at the level of evolved humans. There is no selfishness nor altruism, as we understand these concepts, at the level of the fundamental replicator. These topics and others will be discussed in the following videos from this series. Selfish gene in a nutshell. The fundamental unit of evolution is the replicator. A replicator is anything that can be copied under certain circumstances. So, in a sense, a salt crystal could be a replicator. Unlike salt crystals, however, there is a small error when replicators are copied, so the population of replicators shows variety and changes over time. Suppose a sculptor is asked to copy a famous sculpture. He will undoubtedly not reproduce it exactly, and any subsequent copies of the sculptor's reproduction will, in inverted commas, inherit these small changes. At the same time, other copies will have different mistakes in them, which will also be handed down. How well all of these non-identical copies will fare depends on the conditions they're in, their environment. Firstly, what do we mean when we say, in inverted commas, how well a replicator does? We simply mean how well it continues to replicate, how many new replicators it gives rise to. Evolution knows no other criterion for success. Most mutations will have devastating results, destroying the replicator's capacity to be copied. In our imperfect sculpture analogy, this could correspond to a copy which is so distorted that no future artists will want to copy it. Some mutations, however, will increase the replicator's chances of replicating. Some mutations will confer benefits on the replicator to help it succeed at the expense of other replicators. These replicators will produce new copies which will inherit the mutation, while their less successful brethren will be consigned to history. Thus, we have a natural selection of those replicators most able to succeed, leading to the evolution of new replicator properties. Some replicators will benefit from working together. Suppose replicator A has evolved the ability to copy itself in a new world record time, but only in the presence of a certain substance, say salt. Replicator B, meanwhile, has a mutation which means it attracts dissolved salt, but lacks any special copying ability. Apart, they fare no better or worse than their peers, but together they will proliferate in the replicator population. Over time, evolution will ensure that they are copied together, probably via further mutations physically linking them. This population of replicators, working together for mutual benefits, may, in time, give rise to, in inverted commas, vehicles, physical entities in which many replicators coexist. A vehicle is designed and built by the combined action of the replicators inside it, and successful vehicles will be those which manage to copy their replicators, in brackets, enhance the vehicle. Thus, the population of vehicles will give rise to new generations of vehicles, all inheriting the same replicators. Mutations will continue to occur, and replicators will evolve more and more elaborate vehicles in their quest to outcompete their peers. They may evolve the ability to destroy other vehicles and utilize the materials they are composed of. They may even evolve the ability to manipulate the behavior of other vehicles to their own advantage. These replicators are locked in an evolutionary arms race. Whoever builds the most successful vehicle wins. I have tried to avoid calling replicators, in inverted commas, selfish, or implying purpose because the process is blind. There is no conscious attempt by the replicators to outwit their fellows. It is simply the case that those which do in fact, in inverted commas, selfishly exploit other replicators will tend to be copied more, and more copies of them will be present in the next generation. In biological evolution, the replicators are genes and the vehicles are organisms like us. It is possible that genes could have stayed floating around in the seas. There is nothing inevitable in the creation of vehicles, as Dawkins points out at the end of the 1989 edition. Quotation: "The individual body, so familiar to us on our planet, did not have to exist. The only kind of entity that has to exist in order for life to arise is the immortal replicator." Close the quotation. Immortal because, although vehicles are designed, built, and eventually degrade, replicators march through the generations, albeit as copies. Strictly, the mutations introduced into each new generation mean that most replicators will eventually be changed beyond recognition, but this process is slow compared to the working life of a vehicle. Human genes have taken many millions of years to evolve. Some genes in you have remained almost unchanged for hundreds of millions of years. But if the Bible is to be believed, the human vehicle lasts just 70 years and 10. We can now see why Dawkins called his book The Selfish Gene, even though, in inverted commas, the self-perpetuating replicator, which appears to act selfishly due to the operation of natural selection, but has in fact no conscious foresight whatsoever, close the inverted commas, may have been a more precise title. Oxford University Press probably wouldn't have sold many copies with that. We have looked at replicators and vehicles, which in the natural world correspond to genes and organisms. We have seen that an organism is a vehicle for its genes. It exists because of them. It was designed by them, and its, in inverted commas, purpose is to get them copied by whatever means necessary. So let us now turn to two important questions. What exactly is a gene, and what happens when we apply Dawkins' theory of genes as replicators to the biological world? Continues in the following video. Thank you for listening. Bye!